Alright, so I'm going to be doing question number 1 from the 2011 released FRQ. Alright, so for letter A, we need, what we're trying to do is find out if the speed of the particle is increasing or decreasing at time t equals 5.5. We need to give a reason for our answer. So the speed is increasing when acceleration and velocity have the same sign, plus or minus, and speed is decreasing when they have a different sign. One is positive and another one is negative. So to figure this out, we need to plug in time equals 5.5 in both the acceleration and velocity functions. So we get v of 5.5 equals 2 sine e raised to the 5.5 divided by 4 plus 1. You end up getting a final answer from that of a negative 0.45337. So we have the velocity is negative. So let's plug in 5.5 for the acceleration. So we have 1/2 e raised to the 5.5 over 4 cosine of e to the 5.5 over 4, and that ends up equaling negative 1.3585. So as we can see, both of the acceleration and the velocity are negative, which means the speed is increasing. So our final answer is the speed is increasing at time equals 5.5 because velocity and acceleration have the same sign. Letter B is asking us find the average velocity of the particle for the time period of 0 to 6. So to find the average velocity, we want to find the area under the curve of the velocity function and then divide that by the total amount of time, which is 6 seconds. So the integral of velocity is the total displacement, not the total distance. We'll get to that later. And this is in meters. So if we divide that by the 6 seconds, we get meters per second, which is velocity, which is unit for velocity. So what we do is we do 1/6. That's the total amount of time. That's what we're dividing by. Then we do the integral from 0 to 6 of 2 times sine. This is the velocity function of e t over 4 plus 1 dt. Don't forget to do that dt, that's very important. So on our calculator, what we do is we do and we take that, divide it by 6, and that equals 1. That's our final answer. That's 1.949. So for here, you're getting 1 point for the integral. So you can have this whole thing, or you can just have the 1/6 integral from 6 to 0. And instead of writing this all out, you could do this should be a parentheses. You could just write v of t, which is the velocity function, and keep that dt in there. And you still get your same points for that, and you get 1 point for the answer. Part C is asking us, find the total distance traveled by the particle from time 0 to time 6. To find the total distance, we need to integrate velocity on the time period of 0 to 6. But if we were to just integrate the function, we'd be including all the times there is negative distance, or when distance is traveled backwards. This is displacement. Instead, we need to add absolute value symbols to make sure all the distance that we're getting is positive. So we have distance, which is x of t equals the derivative, or sorry, the integral from 0 to 6 of the absolute value of v t dt. To do this, we do with that, you get a final answer of 12.573. Alright, here again you're getting a point for the integral and a point for the answer. This is fine. This is enough to get your point for the integral. Finally, part D. So from time 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So what we need to do is set the derivative of the position function equal to 0 to find the critical number. That's where the x value, that's the x value of where the position function changes from increasing to decreasing, or vice versa. Luckily, we already have the derivative of the position function, which is just the velocity function. So we set the velocity function, which is 2 sine e raised to the t over 4 plus 1 equal to 0. If we solve that, we get equal to 0. We get 5.19552. So, is that our answer? No. That is not our final answer. This is the time that a particle changes direction. If you remember, the question is asking for the position of the particle at that time. So, we're just going to let b equal 5.19552, so we don't have to keep writing it out. So the position at time b, which is x of b, equals the integral from 0 to b of the velocity function. We can just write v of t because we already wrote the velocity function up here, dt, and then we need to do plus 2. So plus 2, the reason why we're adding that is because at x of 0, the position at time equals 0 is 2. So we're getting all this and then adding 2. If we plug so we get a final answer, so we get this, and we add 2 to that, and we get our final answer, which is 14.134. So for this one, again, we're getting a point for this integral, this whole thing. We're also getting a point for the answer, but we're also getting a point for setting the velocity equal to 0 and finding that time. So that's it for the actual problem. For any additional links that you might want to check out, I'm going to put a Khan Academy link for all the integrals done in this video, if you need any help with that. Also, definitely check out FRQ 2008 on Mr. Farrar's website. Question number 4 is very similar to the one that I did today. It's the same thing with a particle accelerating and decelerating. So hope you enjoy, and thank you all for watching.